Hello, class. So as I was going through this lab simulation, I did come across something that I wanted to go over with you, and that is the calculating of the molar masses. I did these two already, but I wanted to do this one with you together. When you start off, it starts you off with 2-hydroxybenzoic acid, and it has you fill in first the relative atomic masses. So when you show the periodic table, the number at the top is those atomic masses. So carbon would be 12, hydrogen's 1, oxygen is 16. So that's where I got the 12, 16, and 1 from. Now, to get the number of atoms, it tells you that you're going to click on the atom and it's going to fill in here, and then automatically it's going to calculate the mass per mole and give you a total. And so when you're looking at carbon, because hydrogen and oxygen you can see, but when you're looking at carbon for these types of structures, if you have a crosshair like here, that's a carbon, okay? The points are carbon. This one isn't because there's an oxygen there, but all the other points here, those are all carbons. Okay, this point right here, it's a carbon. Okay, and so that's how you can tell where the carbons are. So then you go to oxygen. Oxygen is going to be visible. You can see where the oxygens are. Okay, and then hydrogen, again, those are visible, so you can see where your hydrogens are. And you can always make sure to double check to make sure that you did indeed count everything correctly. And then you check, and then they're going to tell you if you didn't count it right. Okay. And so you have to go back through and make sure that you check. You have 3 attempts to do this. All right. So we go back and we'll look at. All right, I'm going to unclick these just so that I can see them and make sure I've clicked them right. All right, so we go back through. We look at our crosshair, our double bond O here. Okay, and then we click here, 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 and here. And then we click there. Okay, so we want to make sure that we got all of our carbons. Okay. And then we go to our oxygen, and we have our 4 oxygen. We go to our hydrogen and see we missed a hydrogen. So we click that, and then we check again, and we got them all right. Each time you miss something, it'll deduct points. Okay, each activity is worth 100 points. And so as you're going through these, then it'll deduct points. Okay, that has no bearing, just to let you know, it doesn't have a bearing on your grade for this particular lab. All right. All right. So if I see that there's other things that I want to let you know about this lab, I will do another video. All right. Hello, class. So I got to a part, another part that I think that you may not know based on what you're taught in the class. And so for this reaction, we have these two reactants and we form this product. What happens here is that this carbon attaches to the oxygen. But in order to do that, because carbon only wants 4 bonds, and you see it already has 4 bonds, this double bond has to break up, okay? The correct mechanism that shows that is this one. So the lone pair of electrons on the oxygen attracts to the carbon, and this double bond of the carbon breaks apart, giving lone pairs on the oxygen. And so this would be your choice, all right? So just wanted to give you that pointer. All right. If we look at the next one, they have three mechanisms here. For this one, if we look at this picture and this picture, the difference is it's losing a hydrogen. Excuse me. And so there's an extra lone pair of electrons on the oxygen. So you want to choose the picture that shows the electrons from this bond going to the oxygen. So this picture shows them going to the hydrogen. This one shows also going to the hydrogen, but this one actually shows it going to the oxygen. So that's the one that you want to choose. All right, on this next one, we are going from this structure to this structure. And so what is happening is for this particular bond, this portion is coming away. So that means that this bond becomes lone pairs. And there's a double bond created for this one. So lone pairs becomes a double bond. And so the one that shows that is this one. Okay, so this shows the bond going to lone pairs and the lone pairs going to a double bond. All right, so we are at the end of the experiment, and this gives you a summary of what you did, okay, where you did well. And if you want to give feedback to me, okay, where could improvements be made? And then feedback. All right. And then this was the percent yield that I received. Why do you think you did not get 100%? You can put your answers here, and then you will be ending your activity. Okay. So once you ended the activity, you're not going to the next level. If you would like to start over, you're free to. But you're going to click on this. This is your notebook. Okay, so it has all of your information here, your aims, the video that you watched, the comprehensive part, molar masses, all of this is here. Okay, and so you want to, there's a place to download the book. Maybe I have to go back to the beginning. There it is. All right. So you want to download the PDF of the lab book. Okay. So you're going to download it. It's going to pop up as a PDF. You want to make sure that you have saved this. Okay. So it's going to have your name here. And so you want to make sure that it is saved. And so to bring it into, okay, this was the week 5 overview. So let's go back to the lab. All right, so you want to make sure that once you've downloaded, that you do add it to number 5 in your lab. Okay, you want to make sure that you add it as a drop into your lab. Okay, and then you're going to save and you make sure that you submit it. If you have any questions as you're going through the lab simulation, you can do the lab simulation as many times as you want if you want to improve your score, but keep in mind that your score does not have any bearing on your final grade for the lab. All right. Enjoy the lab. Bye bye.